Okay, guys, can you see my screen?
Yes.
Okay, that's great. So today we will study iterations. Iterations are very important. If you want to repeatedly execute some block of code, then we need to use for loop or while loop. So the difference, when do we use which? When do we use for loop? When do we use while loop? So we use for loop when we know the number of iterations in advance. If we know that we have to execute some block of code for 10 times or 20 times or some fixed number of times, which we know in advance, then we will use for loop. So we discussed a very simple example of a list. And in this list, we have 50, maybe six numbers, and we want to print those numbers. So if we have six numbers, 1, 2, 3, 4, 5, and 10. And if I want to print each one of them, so it means that I know how many times I am going to call print function on the on the on the elements of the list. So on the elements of the list. So you can see we will be calling print six number of times. So this type of problems you can solve with for loop. So for loop here, you know the number of iterations. You know how many times you are going to call print. Or let's suppose that you want to do the square of each element or cube of each element in this list. So again, you know the number of times you need to iterate over this list. So list, tuple, set, dictionary, even strings are iterable. So what makes them iterable? So if a object has double underscore iter method, it is iterable. So how can you check whether a list or tuple or dictionary has a double underscore method? So you can check by the name. So this is the name of the list. So all you need to do is uh, call a dir function on this ls. So if in the list of method, if you also have a double underscore iter method, then it means that that data container is iterable. So uh, uh, you can only loop over object if it is iterable. If it is not iterable, you cannot loop over the object. So that's something very important. Again, so uh, we use for loop when we know the number of iterations in advance. And if we don't know the number of iterations in advance, and only thing we know is some condition. If some we don't know the number of condition, we don't know the number of iterations in advance. We can use while loop. That type of problems we solve with the while loop. And while loop executes the uh, code repeatedly until some condition is true. Once that condition becomes false, the code in the body of while loop will not be executed. So that's a difference between those two types of loops, and we can solve all iteration problems with the for loop and while loop. So while loop is more flexible. So you can even use while loop when you know the number of iterations. So while loop can replace for loop, but for loop cannot replace while loop. So yeah, so while loop are more flexible. So while loop can be used when you don't know the number of iterations in advance, and you can you can also use them when you know the number of iterations in advance. But obviously, most of the time you will see for loop. It is the for loop that you will see in data analysis, because we are storing data in list or tuple, and we know the length of the data collection. We know the number of iterations we want to perform. So most of the time it is for loop. Okay. So in all languages support iteration, and if you are coming from our background, the syntax for or while loop may be different, but the crux is the same. The crux of iteration is the same in two languages. So there is not much difference. So yeah, okay, okay. So here, basically, this is a list. I just want to create a list, and you can see this list has double underscore iter method somewhere here. Where is the double underscore iter method? So what you can say about this list? Is this list iterable or not? Iterable or not? What can you say?
Iterable.
Yeah, it's iterable. It is iterable because it has double underscore dunder method. So dunder iter method. So that's very important. So you can only loop over the elements in a data container if it is iterable. Otherwise, you cannot loop over. So that's something very important. Okay. So this is how to check it. Create drawing. Okay, so let me discuss the syntax of for loop. Okay, so let's discuss the syntax of for loop. So basically, this is a very simple syntax of for loop. So this is what the for loop look like. So the for loop starts with a for keyword. Okay, for keyword. Every time you want to use for loop, you will start with a for keyword. So that's something important. Then you need a short variable name. It could be item, it could be X, Y, Z, I, J, K. So usually you will see it's I or J or K, a small variable name. Then you have this uh, keyword in. In is in it's a membership operator, and then you must have iterable. So you can have a list, you can have a tuple. So yeah, you can have even a dictionary, and so and then you have a column. Column after column, you will have a indented code, the code which you want to execute for each item in your iterable, for each element in your iterable. This is the code, this is the indented block of code that you want to execute. So this is a very general syntax of for loop. So for loop starts with for keyword. Then we have an item. So it is not required to be an item. It could be anything. It could be IJKL. And then you must have iterable. So iterable could be any data container which has double underscore iter double underscore method. Okay. And after the column, you use indented code. Okay, it could be one statement or it could be a block of statements that you want to execute for each item in iterable. So Python use indentation. Where you have seen indentation before, this indented line of codes there. So we covered somewhere indented line of code. Where did we see it before? Where did we see indented line of codes? Quickly.
Well, we actually dealt with the for loops before in the previous lessons. And when we also set the conditions in the if.
Excellent. Yeah.
It was also kind of
Yeah.
good.
If condition, so if expression is true, then we use colon and
and
indented code.
indentation. Yeah.
Indentation. So indentation gives you an idea that if this is if statement. So this is a if expression. So this indentation shows that these lines of code belongs to that if statement. So if that statement is true, then these block of code will be executed. So you can understand with the indentation whether which the line belongs to which group. Oh, okay, so that's very important. And even Python, when you are defining a function, Python use indentations there as well. So you see indentation in if statements, you see it in for loop, you see it in function definition. So we don't have indentation. Indentation is not used in R. So instead of R indentation, R use these curly braces to define the code that goes in the body of if statement or for loop or function definition. So yeah, but Python use indentation. So yeah, that's important. Okay. So indentation is crucial because it defines the scope of loop's code block. So indentation is very important in this sense. Okay, so let me, uh, okay, okay. So there are two ways of using for loop. So basically, for loop can be used in two ways. One way is to directly loop over the elements. So each iteration, the one way is to directly loop over the elements, and the other way is to create the list of position of elements and then to iterate over the position of the elements. So let me discuss you the first. Let's create the uh, position of the elements. So create some sort of a list for the position of the element. So how many elements we have in this list?
Three.
Three. So the position of this element is zero. This is one. This is two. Okay. So I can create the position of some sort of a list or some sort of a iterable using the range loop, range function. So this function takes three arguments. Basically, first is the from where the iteration will start, from where it will end. So it creates a sequence something like this: 0, 1, 2. This range function with the arguments 0, comma 3, it creates a sort of a list. You can think of a iterable. Okay. And then you can use you can use indexing in the body of the for loop to access each to print each element in a list. Okay, to print each element in a list. So what is the first way? The first way is to loop over the position of the elements. You create some sort of a iterable iterable for the position of each element, and then you are looping over. So let me ask you, what will be the value of, so how many times this print statement will be executed? First thing, how many times?
Three times.
Three times. So this type of problem, obviously, we if we can solve with the for loop because we know the number of iterations in advance. So what will be the value of fruit in the first iteration? Is it zero or apple?
Apple.
So what is indices? Indices creates a iterable 0, 0, 1, 2. So basically this indices is, you can think of like 0, 1, 2. So what will be the value of fruit in the first iteration?
Zero.
0. So then you are using this through, then you are using yeah, indexing. So basically this is 0, fruits, and fruits is the name of the list. So what will be printed in the first iteration? Apple.
Yeah,
Okay.
because actually it
So
applies the indices to the list of fruits, as it was
yeah,
stated in the screen function.
yeah. So what will be the value of fruit in the second iteration?
Banana. Oh,
Is it one or banana? So for in what is so fruit is the so what is the value of fruit? This fruit in the second iteration. So it is one. Okay, it is one, and it is one, and here it will be one. So like fruits is the name of the list, and we know how to access a single element from a list by specifying the position. So one will give us banana. Okay, and fruit for the third iteration, the value of the fruit will be 2, and we know the 2 will give you orange. Okay, so here what I'm trying to do, this is the first way of using for loop. The first way of using for loop is to loop over the position of the element. So here you have created a iterable for the position of the element. So you are not directly looping over the elements. Okay, you are not, you can do that, and we will see that you can directly loop over the elements, but you are looping over the position of the element. So this will give this indices give you the position of the elements in fruits list. So position of this apple is 0, 1, 2, and you are using range function to create a iterable for the position of each element. So range takes like so let me show you what's the range. So okay, so range, you will put the cursor inside the parenthesis, then you will press shift plus tab, and you will see. Okay, so range takes start. So this 0 is start. Okay, again I have to press. Then you have a stop and a stop and step. So you can do like step here is 1, it could be 2. So here again, so if I yeah, okay, so yeah, so this I'm looping, I'm looping over the position of the element. So that's very important. And I can loop directly over the elements as well. So let me, you will see the difference. I mean, this difference will be clear to you. So, okay. So here, so what do you think? What is the X in the first iteration? Is it 0 or apple?
Zero.
Up. It's apple.
Apple. So I am directly looping over this fruit list. I'm not creating the position of the elements. I'm not creating some iterable for the position of the element. So this X is apple in the first iteration. So it will be directly printed. In the second iteration, X will be assigned the value of banana. So then the banana will be printed. Then the X will be assigned a value of orange, then orange will be printed. So there are two ways of using for loop. One, you can directly use over the uh, elements. Here I'm directly looping. So this fruits is a list. Okay. Here this indices is an iterable for the position of each element in list. So here you can think of this as a list which gives the position of each element of the list. Okay. So yeah, here you are not directly looping over the element. You are looping over the position of the elements, and then using uh, indexing in the body of for loop to access or to print each element. Okay. And here you are directly looping over the element. The X uh, takes a value of the element in a list. Okay. Here, fruit takes the value of the position of the element in a list, position of the element. So 0 here, 1 here, 2 here. Okay. Yeah. So fruits for the first iteration, fruit is 0. For the second iteration, fruit is 1. For the third iteration, fruit is 2. And then you are indexing it. So yeah, is it clear to you? So is it clear to you what's the difference between two ways of using for loop? Can anyone
Yeah.
summarize?
Yeah, the second one is much simpler than the first one.
Okay, so I mean it's up to you whatever you want to use, whether you want to create iterable some sort of a list for the position of the element. I mean, you can here, if it is confusing you, let me show you list. It's up to you. I mean, sometimes, okay, so print indices is, it will, so you can think of this as a, so yeah, so you are, this is a list of the position of the elements. Okay, list of the position of the elements. And yeah, obviously second one seems to be very easy, but at times you need to use both. The both produces the equivalent results, but this type of syntax is more popular in R. In R, you loop over the position of the elements. Here, you can directly loop over the elements. Okay, directly loop over the elements. So yeah, okay. So what do you think? What will I get if I run this code? Anyone want to explain this code?
Well, we are introducing the variable 5, and then we are creating an iterable kind of list, perhaps, yeah, with a range of 1 to 11. Actually, these are values. It's not positions, right? So, and then we use I as one of the variables that's going to be changed within this range. So it will go from 1 to 10 because the last one is going to be excluded.
Yeah, excellent.
And instead of 11, we're going to get this 10.
Yeah,
So then we're going to write this multiplication table for 5, for the number of 5.
yeah, yeah, excellent, excellent explanation. Very simple and excellent explanation. So obviously this 11 is exclusive. So it will go from this one, start index is inclusive, 11 is exclusive. So it will go from 1 to 10. So you can see that it is going from 1 to 10, and 5, it's a sort of a, like if I want to use some other table, multiplication table, maybe if I use, you can see it's 6, so you can print tables. Okay, so I mean that's yeah, okay. All, any functions, very powerful function. So let me show you the, so all, what's the argument it takes? All, it takes iterable. So remember that all, any takes iterable. So all will return you a boolean if all the it takes a iterable, and iterable maybe a list of true falses, or tuple of true false. That is what all function take. All function is very useful, and you will use all a lot, in all a lot. So if all the elements of an iterable are true, all will return you true. If even one of them is false, all will return you a false. And any function, again, it takes an iterable, and iterable of Boolean values. So it will take true, false. So if there is at least one true, if there is at least one true in an iterable, it will return, any will return you true. So yeah, and there you will see their use cases a lot. So yeah, again, any and all both take iterable. And what type of iterable? So iterable in which all the elements are of Boolean type, true, false. Okay, true, false. So yeah, let me show you. So what do you think if I run this? What will I get? What will be returned? True. Okay, because all the elements in a tuple are true. So what do you think? What should I get now?
False.
False. What do you think? What will I get?
True.
True. Yeah. At least one true, I will get true. So if there is one true, I will get true. So all and any are very useful. So let me see. What do you think? What should I get? False. So this
False.
not true is false. Okay, not true is false. Okay, yeah. So any all are useful, and any all functions basically takes iterable as a argument. And here, how you know about the function documents? I mean, what is the way to know about the functions document? So what you will do, you will type any parenthesis, and within parenthesis, you will press Shift plus Tab. So you can see, yeah, you can see the document. Okay, iterable, and if the iterable is empty, return false. So yeah, you get some information about function, what type of argument it takes. Okay, so you can even type about dir, put the cursor inside the parentheses, round brackets, and then Shift plus Tab. You see, okay, okay, it's if, and then this is the information. And if you are a beginner, it's good to like call help. It's good to try to read what the different functions says. So yeah, that's what are their arguments. It's very important. Okay. Again, so what's the difference between for loop and while loop? Quickly. When do we use which?
For loop is used when you know the number of iterations. Well, the while loop.
Yeah. So the for loop is when we know the number of iterations in advance. Okay. While loop is used when we don't know the number of iterations in advance. All we know is we want to execute some code as long as some condition is true, and the code should not be executed once the condition becomes false. So that's when we use while loop. And while loop are more generous. You can even use in cases where we use for loop. But yeah, it's not advisable. But if you have a fixed number of iteration, if you know the number of iterations in advance, you always use for loop. Yeah. Okay. So, I mean, loops are very important. You can sum a range of numbers. Okay. You can sum a range of numbers. So let's suppose that if I want to add all the numbers from 1 to 10. So how to do that? So you can use for loop. So yeah, here what I'm doing is basically this range. you can think of it, it creates an iterable. So it creates an iterable from 1 to 10. Obviously 10 is not exclusive, but I want to add all the numbers from 1 to 10. So I'm adding 1 in end. So that it will make 11. This will become 11. So so it will create a sequence of numbers from 1 to 10, and then we can loop over. So what I'm doing here, I'm initializing. Sum of the results is 0. And so for the first number, okay, let me clear that. So what will be the value of num in the first iteration? What will be the value of num in the first iteration?
Okay, it's going to be 0.
0. Yeah, it's going to be 0. So you can think of 6, 7, 9, 10. Yeah. So yeah, it will add all the elements. So what it is doing, so basically this plus equals to is nothing, but you can also write, if it is confusing you, maybe this assignment operator, if it is confusing you, you can also write in this way. So for C plus. Okay, so what is the value of sum underscore result in the first iteration? When num is 0, what is the value of it?
It's going to be 1.
It's 1, or yeah, it's gonna be 1. Yeah. So yeah.
Because we're adding to 0, we're adding the starting, the value of the starting position, and
Yeah.
this is 1.
Yeah. So
0 plus 1 is 1.
0 plus 1 is 1. So this basically will cumulatively add the number. So this syntax will cumulatively add the number. So if you want to yeah, cumulatively add, so this is what it will be done. And yeah, but obviously, yeah, so this is, you can think of this is your own way of using sum function. I think we have a sum function to sum all the elements in a it's not a function, but let me show you what I'm trying to say. Range 0, 10. So yeah, you can think of like yeah, this is, you are summing. This is your own way of summing. You are writing a low level code to sum all the elements in some list, or yeah, you can do it, and it's a very powerful idea. Okay, so yeah, and here, okay, so let me show you. Yeah, 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 and if here it's 1 to 11. So you will get the same results. Yeah, 55, 1 to 11. Yeah, so you can think of that this code is your own code to sum elements in any iterable, in any list or tuple. So this is your own way of creating yeah. And similarly, you can create the average of number in an iterable. It's not very difficult. So what is the length of this list?
It has 7 elements.
Okay, so it has several elements. So for taking the average, we need to sum all the elements, and we need to divide it by the length of that iterable. So that's how we calculate compute average. So obviously we will initialize this sum variable to 0, and we will cumulatively add the numbers, the next number in the previous sum. So yeah, and this is how you will compute average. So this gives you sum of all the numbers in an iterable, and this gives you when you, and then you have in denominator the number of elements in that iterable. Okay, this len nums give you the number of elements in that nums. So that's how you can compute compute average. So this is your own code to compute average. Yeah, I don't know whether yeah, obviously we have these we have functions in NumPy to compute all summary statistics, but just like if you want to do it, yeah, you know how to write this basic code. And if you are coming from a different programming language, you must have run for loop for very simple purposes like summing all the elements in a iterable, or taking average, or even sometimes computing standard deviation, writing your own functions. So yeah, so this is, and even you can take maximum and minimum. Okay, so what is the maximum number here? Probably I should, yeah. What's a maximum number here in this list?
50.
50. So I'm writing my own code to see whether I get, yeah, you can see that I'm this is my own code. Or maybe if I change it to this number to so now the maximum number is 550. So I should get 550. So you can see that, yeah, you can find the max of a list, you can find the minimum of the list. Maybe you should try uh, uh, how to find the minimum of an iterable, how to find the minimum number of an iterable using for loop. Okay, so for solving this type of problem, you need to iterate over all the elements to find the maximum or minimum. Okay, so you know that the number of iterations in advance. You know that the number of iterations will be equal to the number of elements in an iterable for which you are finding maximum or minimum. Okay, so you have to think in this way, how to solve the computation problem, why you are using, whether you need to use for loop or not. You need to use for loop here because to find out the maximum or minimum of a list, you must loop over the whole list. You must take into account all the elements of an iterable. Okay, and this type of problems you can solve with for loop. Okay, so list tuple are not the only iterables. You can even loop over dictionaries, and this is our dictionary, and here we have three key value pairs. This is one, this is second, this is third. So we have three key value pairs. Okay, and so we are calling, the name of the dictionary is person, and we are calling our dot items method on. So dot items method, what it does, so let me call a dot items method first. Okay, so what do you think what it will get? We have studied some methods in dictionary. So dot items, so again, so uh, so is it a method or an attribute? Dot items, why it's a method?
Method.
Yeah, why it's a method?
I think it's a method because you have those brackets.
Yeah, excellent. And method is nothing but a function defined for the object of particular class. So person is an object of class dictionary. So that's why we can apply dot item method here. So dot item method belongs to dictionary. So if it were not a dictionary, we could not have applied this dot item method. So we have differentiated between method and attribute. So attribute does not have does not have parentheses. So attribute is like object object dot attribute. So this is without parentheses, okay? And when you have object dot method with parentheses, okay? So that's a differentiation you need to remember. So obviously both attribute and methods um, are the attribute is also defined for an object of particular class. Maybe list has a maybe one object may have different attributes as compared to another object. Maybe yeah. So that thing is important. So Python is a highly object-oriented programming language. It's not possible to fully discuss object-oriented programming here, but you should be able to differentiate between attribute and method, and you should able to call method on an object of particular class. And it's very important, like we have append extend methods for list, but these operations don't work on tuple. So extend, append, so each data container has its own methods, and sometimes they also share the method names, but each data container has its own method. So like for dictionary we have dot items, but we don't have this dot items for list or tuple or set. Okay, we have some methods for set like intersection, union, which don't work for other data containers like dictionary. So method is nothing but a function defined for an object of particular class. And how to differentiate between method and attribute? Method uh, has the name of the method follows the name of the method is followed by round brackets, and sometimes it takes arguments, and sometimes we don't give any arguments in these round brackets. Okay, so yeah, so yeah. Okay, so this is a list, and this creates a list of tuples. This create a list of tuples. So I think it creates a list of tuples. So each tuple will have two values. So each tuple will have two values. Uh, so 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 here in first tuple we are going to have name. We are going to have key one key one comma value one, key one value one. So in the second tuple, we are going to get key two and value two. Okay. In the third tuple, we are going to get k3 and v3. So what does this person dot items give you? Person dot items give you a list of tuples. And how many tuples we are going to have? It depends upon the number of key value pairs in our dictionary. So I mean, let me show you. It does create a tuple. First, I will uh, run this code, and then I will run this code. And this one, you can see that, oh, it's create a dictionary items. So dictionary item of tuples, okay? And you can always convert into list by like this list, passing this to a list will create a list of tuples. Yeah, list of tuples. So yeah. Yeah. Okay. So we are looping over so we are looping over keys and values simultaneously. So you can loop over iterate over two objects simultaneously in Python. So Python is very, very powerful in this regard. So what we have seen this. So how what will be the value of what will be key and value in the first iteration? Anyone? What will be the key and value in the second iteration?
Age.
Yeah, key in the second iteration, key will be age and value will be 30. Okay, so where you have seen this syntax, basically here this gives you a list of tuple or dictionary items of tuple, but this is unpacking. This is unpacking. So the first key, the first item, or the like, let me so yeah, this is unpacking, tuple unpacking. So basically, you are um, like tuple unpacking. So can anyone define what is tuple unpacking? What is tuple unpacking? So this is a tuple. Okay, this is a tuple. So this key and value. So the key will be assigned name, value will be assigned John in the first iteration. So this is you are assigning the values in a tuple to a variable name. So you have equal number of values and equal number of variable names. So you can think of like key will be assigned name and value will be assigned John. So second is also a tuple and tuple, and then you are assigning the values in a tuple, like the elements in a tuple to two variables, and the name of the variable is key value. So and they will be assigned in the same order. So the key will be assigned age, value will be assigned 30. So key will be assigned city, value will be assigned New York. So yeah, so this is an example of a tuple unpacking. Tuple unpacking. Okay, so you can think of a multiple assignments. So we are creating multiple variables. So here key is assigned, key values are assigned to the respective values, to the respective elements in tuple. Is this thing clear? Do any one of you remember what is tuple unpacking? Okay, all you need to remember from here is you can iterate over you can iterate over keys as well as values on dictionaries. So this variable here, J, is a single variable, but it does not need to be a single variable. It could be more than one variable. So here we have more than one variable, and this creates a list of tuples. So yeah, list of tuples. So yeah. Please go through the tuple unpacking. So in order to understand this syntax, you need to go through tuple unpacking once more time. Okay. Okay. Uh, Let me go through it quickly. So can anyone explain me this code? Try to explain me this code. What does this mean? Maybe take a minute, take a second, and what I'm doing here. Okay, go ahead. Make an attempt. So what is movies? What type of data containers is movies?
So
Dictionary.
Dictionary. Excellent. It's a dictionary. So I want all the movies which have ratings greater than 5. So that is what I'm doing. So here again, uh, so uh, I'm using items method on movies, which is a dictionary. I can use that items method. It will give me uh, maybe you can think of it as a list of tuples, and then I'm using tuple unpacking to assign movie and rating to the elements, to the each element, to the elements of tuple. Okay, and then this syntax basically uh, this is the movies is the name of a dictionary, and movie is a key. Movie is a key. So this will give you the value. Okay, this will give you the value of each, and then you are comparing it with 5. So if it is true, then its rating will be printed. Otherwise, it will not be printed. So all the movies, it will give me the movies which have rating more than 5. So you can see here. So all the movies, Blood Diamond, Fight Club, Dark Knight, Inception. So yeah, the movie ratings. Yeah, that's great. That's great. So here, I mean, for loop, you can again use for loop. So what is it? What type of data container is it?
It's a set.
It's a set.
Set. And set is a collection of unique elements, and the order in the set does not matter. But for loop, like with iter methods, it tracks what are the elements which over which it has already looped over, and what are the remaining elements. Those sets are unordered, but still iter method is powerful, and it keeps a track, like the elements over which it has looped over and the elements which are still remaining. So yeah, it's a set. And yeah, here again, so this is like yeah, so yeah, this is like, yeah, set. And obviously you here you are summing the all the elements in a set, so that's not very difficult. Okay. Yeah, you can also remove or modifying elements in a set. Okay. So can anyone explain me this code? Okay, let me this code. Can anyone explain me this code here? What I'm doing here? So I'm creating a new set, modified set. If the elements in my set is divisible, completely divisible by 2, or if it is an even number, then I will multiply it by 2 and store it in modified set. Okay, modified set. That's what I'm doing it. Okay, so yeah. Yeah, so this is, I mean, it's very important. You should able to read the code quickly. These things are not very difficult. These things are very simple code. And yeah, and you can even use a nested for loop inside the for loop. So we also encountered situations where we can use the nested for loop. Okay, let me explain you first the while loop. While loop is important. So where do we use while loop again?
When the condition is more important than the length of a container.
Yeah, so we don't know how many times we need to execute some block of code in advance. We don't know the number of times we need to execute the block of code or code. All we know is some condition. As long as some condition is true, we should be executing that code. So that's type of problem we solve with while loop. And just to give you an example here, okay. So basically here what I'm doing, I'm creating you don't need to, I mean, understand it, because I did not explain you how to import modules. Like this is not a part of this course. Maybe when I will teach NumPy, Pandas, Matplotlib, then I will go into detail. But here I'm just creating a sequence. I'm just creating a sequence of elements, and I'm creating 15 elements, randomly picking from between 1 to 100. Okay, so I don't know, and every time I run this code, I get a different sequence. Okay, so I don't know. So if I want to, I want to create, I want to create a list in which I want to store all the elements until I meet a first element which is completely divisible by 50. So how many elements will go into that list if this is a sequence? I want to store all the elements in a separate list until I meet an element which is completely divisible by 5. So which element is, what is the first element which is completely divisible by 5?
50.
50. 50. So 50 is the first element. So if I run this again, the 65 is the first element which is completely divisible by 5. So if I run again, so yeah, so we don't know in advance, how many elements we will loop over until we meet an element which is completely divisible by 5. Okay, so that type of problem will be solved by while loop. Okay, that type of problem will be solved by while loop. Okay, did you understand what I'm trying to say? So this again, let me show you. Maybe run again, run again, run again. So what is the first element divisible by 5 in this list?
10.
10. And so you don't know at what position, you don't know whether you don't know the number of iterations in advance. So let's suppose that you will get all, you will store all these elements in a list, because you are storing all the elements in a list before you meet the element which is completely divisible by 5. So you don't know the number of iterations in advance. So this time you have like 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I run the code again, now what is the first element divisible by 5? Completely divisible by 5.
35.
35. Okay, 35. So all these elements will go into the list. So you want to store all the elements before you meet a first element which is completely divisible by 5. So now you have a different number of iterations. Okay, so this type of problems where you don't know the number of iterations in advance, this type of problems you can solve only with the while loop. So what is the syntax of the while loop? So while loop always start from the, so you have to initialize counter. So okay, so you have to initialize counter, and with each iteration you also have to update that counter, increase that counter by 1. So this is the way to increase the counter by 1. So what do you think? So let's suppose that this is the list. Okay, so what will happen in the first iteration? What will happen in the first iteration? Can anyone explain me this while loop for the first iteration?
We're going to loop through the list. As far as I understand, that's the list above, right?
Yeah.
So, and then we set the condition of
okay, there's a break.
Yeah,
okay.
well, we have said actually at first we're setting the empty list. We are going to add numbers to that list, and we're setting the step. And the initial step is 0, 0 position, and then every new position is the previous step plus 1.
Yeah.
So then we are setting the conditions, and the condition is that the number, the value of the number on the position in the list, whether the remainder is 0 or not. If the remainder of the division by 5 is 0, we break. This means that the target value is found.
Yeah, so I did not explain you break. Sorry for asking you a question before explaining a break. But here, what I'm trying to maybe 69 is the first. 69 is the first number, so it is not divisible by 5. It does not leave
Yeah.
a remainder of 0. So this part, the code, a break does not operate. And
Yeah,
this
this means that we are not going to break. We are going to go to this not divisible by 5, and this value of 69 will be appended to the list non-divisible by 5 that was said before,
and then we will
to this empty list. And then we are going to the next iteration. This means the new step, where the new position is going to be I, which means 0, plus 1.
yeah.
And then the next is going to be
Sorry. Yeah. Go ahead. Explain. Sorry. I mean, I have to. Yeah. Please explain. Yeah. Yeah. Please explain. Sorry, I have to mute someone. Yeah, because of sound, and it muted everyone. So yeah. Yeah. Okay. So yeah, you are right. And here, remember that in while loop we have to increase I counter by 1 in each iteration. So that's something very important. And what type of problems we can solve by while loop? In the problems, computation problems in which we don't know the number of iterations in advance, and this is the most important thing to know. And obviously, syntax is not very difficult. We have to start the counter I equals to 0, and then we have to increase the counter by 1 in each iteration. Okay, so then this code, once it is iterated, once this I is updated, it will this will become, for the next iteration, I is 2, because we have, at the end of the first iteration, we have updated I from 0 to 1. So this will be evaluated for this 14 number. And again, this is not completely divisible, so it will not break, and we will add the number to our list. So yeah, I will explain you what do we mean by break, continue, pass. These are very important. Uh, keywords, and yeah, so these are important keywords. So okay. Again, you can use this. You can use this at home. So here we are guessing a number. Obviously, we don't know different how many guesses we will need to guess a number. How many guesses? How many? Sometimes maybe some person may guess the number rightly in 5 guesses. Sometimes a person. So we are using while loop. So maybe you can go through the syntax, and it's interesting to play that game. Okay, so so let's me start. Maybe you can do it home as well. So which number should I enter? If a number is greater than 50, so I should put 75. Okay, so the number is between 50 and 75. So what is the median number? It's 62. Okay, so 62. So the number is between 62 and 75. So maybe what's the center number between 62 and 75? Maybe 68. Okay, 62 and 68, 65. try a lower number. 64, 63, 63, yeah. And it took me 7 attempts. So yeah, it took me 7 attempts. So you can think of how many attempts it takes you to guess the number right. Obviously, if you start with 50 and then if it is less than 50, then you should go 25. The next guess should be 25. If it is higher than 50, maybe you should start from 75. So on average, you will take, if you follow this type of strategy, on average, you will take less number of guesses to reach the right number. Okay. So, okay. So now this is very important. So, I mean, I want all of you to pay attention. So the understanding. So break statement, you can use break, continue in both for loop and while loop. Okay, so you can use break. So break basically terminates a loop prematurely. It means that once a break operates, once a break statement comes into effect, the remaining iteration it breaks out of the remaining iteration, so it will not perform the remaining iteration. So yeah, and continue only skip the rest of the current iteration. It will not execute the code, the remaining code for the current iteration. So yeah, maybe if I explain you with this example, that will be great. Let me first of all, I have to do, so I don't want you to see the output, maybe. Okay, where I am here. So what will be the value of I in the first iteration? In this case, what will be the value of I in the first iteration?
I think it will be 1.
Yeah. So it is 1. It means that if 1 is less than 3, it's true. Okay. So what about this if statement for if I is equal to 1? Is it true or false? I is less than 3, it's true. So this continue will take effect. So this continue will take effect. It means that the remaining iteration. So this code will be ignored. All this code will be ignored for the first iteration, because this continue takes into effect. And what does the continue do? Continue basically ignores all the remaining code for the current iteration. So it will not print any number. Okay, it will not print any number. It will not evaluate this. It will not evaluate this expression. This. Okay. So what happens if I is what is the value of I in the second iteration? What's the value of I in the I is 2. I is 2 because it creates a sequence of numbers between 1 and 11, and 11 is not exclusive. So I is 2 in the second iteration. So okay, so what will happen to this code in the second iteration? Do you think that the continue will take into effect or not?
It's going to continue the looping.
Yeah, it will take into effect, and taking into effect means that it will skip the remaining iteration, whatever code we have in the it will be skipped. So this 2 will not be printed. So this code, because continue takes into effect for the current iteration. So yeah, what about if I is for the third iteration? What will happen for the third iteration? So what about this for the third iteration? So 3 is no zero. Yeah, third is 3 is less than 3. What do you think? It's true or false?
It's false.
Is 3 less than 3? False. So this
False.
yeah, this continue will not affect. will not take into effect. Okay, so because this continues in the body of this if loop, so it takes into effect only if condition is true. But if condition is false, so this continue has no effect. So then this print this will be printed. Okay, 3 will be printed, and then 3 greater than equal to 5. Is it true or false? 3 is greater than or equal to 5. True or false?
False.
So false means that this break will not take into effect, okay, for the third iteration. Let's see what happens for the fourth iteration. So fourth iteration, I is equal to 4. This is I is equal to 4. So it means that this is false. Continue, which is in the body of if loop, will not work because continue, this only works if the if condition is true, but it is false. So the fourth will be printed. And what about this if 4 greater than or equal to 5? Is it true or false?
It's false.
False. False means that the break will not take into effect. Okay, because break is in the body of this if. So 4 will be printed. So previously we printed 3. Now 4 will be printed. What happened for the fifth iteration? 5 less than 3 is false, so the continue will not take effect. 5 will be printed. And what about 5 greater than or equal to 5? What about this?
The looping will be broken.
Yeah, 5 greater than equal to 5 is true, and it will
break.
go into this break. So the remaining iteration like 6, 7, 8, 9, 10, they will not be executed. This code will not be executed. So what is the result? Only 3,
4, and 5 will be printed.
5 will be printed. 3, 4, and 5 will be printed. Very, very important. So you can use these continue and break in for loop as well as while loop. Okay, so that's something important. So yeah, yeah. Okay, so can anyone summarize now the difference between continue?
A question.
Continue.
I want
Question?
to ask a question.
Go ahead.
Yes,
Go
I
ahead.
wish to know the importance of knowing this while and for loop in our normal life. How can we apply it in our normal life?
How you can apply in your normal life?
Yes.
Sorry, can you?
How is it? Yeah, I
I
was
mean,
trying to ask how is it applicable in our
yeah,
life, advantageous?
yeah. I mean, when you will solve real world computational problem, especially statistics, data analysis, or machine learning, you will come across a lot of problems that you can only solve with the for loop. So maybe as I gave you an example of adding numbers in a list, you cannot solve it without for loop. Okay, you cannot solve it without for loop. So you have to loop over each element. Yeah, and the whole data analysis is basically based on for loop because like your data is in columns, rows or columns. So you have a fixed number of columns and fixed number of rows. So so let's suppose that if you want to iterate over any column, you will use you want to like multiply each value in a column by 2, or you want to uh, do some sort of another operation, you will be using for loop. Behind that will be a for loop. So yeah, I mean, in real world is full of examples, data analysis, statistics, machine learning, where you will use for loop. Obviously, for loop is more common than while loop, but sometimes when you are you also use while loop because uh, you also give condition. Yeah, maybe yeah, conditions. Yeah.
In natural
Question.
language processing, it is used.
Sorry, go ahead. Yeah.
In natural language processing, it is used. Both loops are used widely, especially when you work with corpora, for example, or when you, for example, use pandas, you go through the
Yeah,
table, and the table is actually a dictionary,
yeah,
and you iterate through this huge dictionary, and you have something like 10,000 entries.
yeah,
So, and the computer
yeah.
analyzes all these entries according to conditions.
Yeah. So, I mean, yeah, for loops are something very basic and very popular. So that's why, and every function you will write, almost every function you will write, you will be using for loop in the body of that function. So for loop is something very popular. Though Python is also a sort of a vectorized language. We have map functions because of the functional language because of functional programming. Like we have a map function where you can apply a function to each element of an iterable. So you don't need to write for loop explicitly. But even in map, somebody else has written a for loop for you. Okay, so map, maybe we will study map. Uh, how many of you know map or heard about map or apply family of functions in R? Apply family of functions. Apply. So apply family of functions. So in apply family of functions in R, somebody else has written a for loop for you. But obviously, you cannot perform a function to each element of an iterable if you are not using for loop. Okay, so for loops are very important. Similarly, while loops. I tend to use while loop less often. Uh, but yeah, there are situations where I use a while loop. So any questions regarding this continued break? Did you guys understand what does this mean? Or can anyone summarize the difference between break and continue? One more time, summarize it. Maybe what we have studied. What do we mean by break statement? What do we mean by continue statement?
Well, we use continue statement while the conditions set are true. And this means that the iteration is going to continue we're going to iterate through each step with a new step through each position in the list or in a set or in the dictionary. So far, the conditions are true. With a break, as soon as the condition is reached, the looping stops.
Yeah. So the break statement is once a break statement takes into effect, the remaining iteration, the code for the remaining iteration will not be executed. Okay, that's it will break out immediately, break out of the of the for loop and continue. So the if the continue takes into effect for the second iteration, so this part of the code will be executed for the second iteration. If the continue statement takes into effect for the third iteration, this code will not be executed for the it will not be executed. It will act as if it has not seen this code if continue takes into effect for the third iteration. So yeah, it's very important, yeah, to understand them. And you tend to you there are situations, real world situations where you use continue, where you use break. Yeah. So let's suppose that if you want to modify some column and there is one column which you simply want to skip and you don't want to apply your modifications to that particular column. So you can create a condition with continue for that with a continue. So all the modifications will be applied to all other columns in a pandas data frame, but not one column. Yeah, or you can exclude column or columns using this continue statement. So yeah, that's important. Okay, guys. Today, okay, let me see where we are in terms of our course. Okay. So, I mean, this is important. You can see break, continue, more example of break and continue. Maybe I ask you, I have few minutes. Uh, So what do you think? What will happen? No, I mean, you can see it at home. I mean, yeah, that's, I won't ask you. Okay. So list comprehension is another form of for loop. In list comprehension, you also use list comprehension is like a for loop, okay? A concise way of writing a for loop. Uh, and list comprehension, set comprehension, dictionary comprehensions, all these are based on for loops, okay? But they are a concise way of writing for loops. So you don't need to explicitly create an empty list, then perform some operation and on element and populate that empty list. So for list comprehensions are very powerful. So you guys can, I mean, see this at home, or maybe I will cover it tomorrow. So tomorrow I am planning to have a lecture, though it was not originally planned because we have not touched the functions yet. Functions are super important. And if it is okay for you guys, I mean, we can have a class tomorrow. Otherwise, I mean, I can record a video and upload it on my Facebook channel, Facebook page. So whatever is convenient to you. So yeah, it's up to